The first page we're going to study of the two-story plan is a site plan. If we look at the right-hand side of this page, we can see the title block. The engineer company for this particular site plan was MMS, and as you can see above, they are civil engineers, land planners, surveyors, architects, and environmental specialists. This company is located in Iowa City and also has an office in Cedar Rapids. Also in the title block is the lot number 195, in the Cedar Springs development, Part 6. And these drawings were done on February 16th of 2010. Note the scale for this drawing is 1 inch equals 60 feet. Quite a bit smaller scale than what we saw in the previous residential plan. When you take a look at the site plan, you should notice right away that the house appears to be very small. The house is located in this area right here. You can see the overall footprint of the house. In relation to the lot, which extends way back into this location, the house again looks pretty small. In fact, this house is about 3 times the size of the first house that we had studied. The difference being lot 195 is nearly 4 acres in size. So let's look at a few other details about this particular lot. If I zoom in here to the right-hand side, you can see that there is a storm sewer drainage easement. If we recall, easements are shown with the dashed line there. They represent access, typically utility access. So things like stormwater, electrical, telephone, and gas. Those utility companies have access to that location. So even though you may own the property, they have rights to access that area. In this case, this is stormwater. And that stormwater, again, goes from the front, or Poplar Lane, the street that this house is on, back towards what is the northeast corner of the house. And eventually that would filter down into a ravine. It's hard to see on this particular plan because there's no topography. So notice where the 30-foot easement begins. That is the bottom of a ravine. Other things that are different about this site plan than the previous one we looked at is the addition of elevations of the foundation. If we look in this corner of the plan, we can see building corners A through F noted. Those correspond to the same letters on the actual outline of the house. And those are given to represent the different heights of the concrete foundation wall. And that is relative to the different heights of the dirt surrounding the foundation. So for an example, we want to ensure that the foundation height is higher than the outside dirt level, so that we have proper drainage away from the house. If you look at the arrows surrounding the house, you can see the engineer has specified how the water should drain away. In the front of the house, it goes towards the street, or on the sides and back, it goes to the back of the house. If I zoom in closer to the street area, we can see a couple different utilities. The sanitary sewer, as well as the fresh water. The last line here shows the sump pump discharge line. So in this particular jurisdiction, they require that the sump pump, the water from that, be drained into a drain along the curb and not just discharged to the outside as typical in many different developments. The second page of the two-story takes us to the elevation page. Here we can see the front, the rear, the right, and the left side elevations. Similar, but a few differences to what we saw with the first ranch plan. First, you'll notice that all 4 elevations are listed on the same page. However, the difference in this case is the front elevation has a scale that is twice as big as the back, the right, and the left. This is just a personal preference from this particular designer. We can clearly see the basement height of 9 foot 1/2 inch, the main floor of 9 foot 1 1/8 inch, and the upper floor of 8 feet 1 1/8 inch. So all 3 levels of this house have different ceiling heights, which is not uncommon for new construction today. Additionally, we can see the roof pitch of the house is 8-12 in all locations, and this is what we call a hip roof. so it slopes up from all four sides. Moving on to the main floor plan, we can see the architectural style again is a little different here. One of the primary differences you'll notice is the use of different notes for the size of the windows. So for example, the den window has a width of 7/0. That stands for 7 feet 0 inches, and a height that is 6/0 for 6 feet 0 inches. We can also see the front door has a width of 3 foot 0 inch. Does not list the overall height for that door. Moving on to page A3, we are now on the upper level floor plan. One difference between this and the other ranch plan is the open to below area. If we zoom into this area right here, we can see that the front door is below us here. When we come into the foyer, notice that there's not a floor above. So that's why we see the open to below note here. So if you can imagine, the staircase comes up, makes a turn, comes up to this upper landing, and that would overlook down into the entryway. Another difference to note is the dashed lines that represent the lower roof here to the left for the front porch, as well as the garage on that lower right-hand corner. This next page, F1, denotes the foundation plan. Differences with this one are the interior continuous footings. Within the house, we can see this first long footing that is just to the left-hand side of the staircase going down to the basement. This other smaller interior footing is to decrease the span of the floor joists above. Lastly, this footing in the garage will have a post above that will carry the floor load of the second floor above. Now that you're familiar with the architectural drawings of the two-story residence, we're going to take a look at a few more detailed drawings. Specifically, we're going to look at roof trusses and floor joist shop drawings. So to start us off, we're going to take a look at this slide here that shows a perspective view of the trusses on the upper floor of the two-story. As noted before, we have a hip roof. Additionally, we can see two gables that face the street. I've color-coded the trusses so we can start to articulate the differences between the different types. It's another view of the same upper floor, looking at it from the rear perspective. This is what we call a plan view, looking straight down. And here's a layout from the truss manufacturer. They detail every single truss, label it a certain letter and number, and so every truss has a specific purpose. So let's isolate a few trusses and look at them in more detail. So in this picture here, we can see that we have two different colors, the gold color and the purple color. The purple color are what we call girder trusses. So girder, G-I-R-D-E-R, girder trusses support more than one additional truss. So it's like a truss that carries a load of other trusses. The gold trusses, you can see, are different sizes, different shapes. You can see how they start to stair-step their way up to the ridge, up to the peak. And that forms that hip roof portion of the house. A little bit more detail from the other side, we can see the labeling of each truss. The purple one up front, CG1, represents the girder truss, oftentimes with the letter G in it. The shorter purple one, we can see BG13, again another girder truss. That will support more yellow trusses that come off to the right. And then beyond that, we can see B12, 11, 10, 9, and such. Before we look at any individual truss, let's get an idea of some of the terminology used in building a truss. Looking at the bottom of this truss, we can see a normal span dimension given from left to right. We need to understand that this would be an exterior wall. This would be your double top plate. The same over here on this side. The span then would be from the outside of the wall to the outside of the wall. Sometimes we refer to it as clear span, and that would be from the inside of the wall to the inside of the wall. Clear span refers to the part of the truss that doesn't have any support underneath of it. If we look at the top of the truss, we see this 2x, typically 2x4. That's called a top cord. Each of the pieces of the truss are connected by what we call a plate. Inside the truss, from plate to plate, we see what's called webs. There are many different types of truss configurations to be had. These are just a small sampling of all the possibilities. Now, as mentioned earlier, we have a scenario where we have a girder truss that holds up the other trusses that are adjacent to it. In this picture here, you can see how the trusses are connected to each other. So for an example, in this picture we can see this truss comes into another truss that carries a load of this one. There's no post underneath of this. So this girder truss here has to support all the load coming in from these trusses here. So later in this lecture, we're going to talk about truss B9. And as we saw in the perspective picture, B9 is one of the gold trusses that stair steps its way up to the peak. So here's what the actual truss shop drawing looks like from the truss manufacturer. Here we're looking at truss lettered B9. You can see that here at the top. Below that is information about the truss in terms of its capabilities of supporting weight. You can see the measurements given here for those amounts. And then additionally, we can see letter A discusses additional bracing that needs to be put on, along with letter B over here, the 2x6. It also gives dimensions, the overall length, the slope of the truss, and of course the height. Additional information can be used off of this for the framers to determine where lateral bracing and additional bracing during construction and post-construction need to be placed. Shop drawings like this are very common in the industry and are important for both designers and contractors to understand. Moving on to the floor joist layout, we can see each of the floor joists identified here for the 2-story. We're looking at the main floor plan in this case, and you can tell that by looking at a few different details. Specifically, over here on the left, you may recall that there's a fireplace that sits in this corner of the bump out. And back here we can see the bump out there off the kitchen. So each one of these double lines represents a floor joist, the longest of which go right here through the middle. We can see that the quantity here is 5, and they're 48 feet long. We can also see up here there are 8 that are 18 feet long, again starting with this one, continuing all the way through until this one. Over here where the fireplace is at, we can see that there are 4 that are at 7 foot in length. As we move up to the second floor, we can see more of the joists. They go from the front to the back. And something a little bit different here where the open to below area is at. As you may remember, the stairs come up like this, and we get to the landing at this point. Well, as the joists come over, they're interrupted by an LVL that carries a load of these joists. Additionally, on this plan, we see these numbers with the pound sign after that. This represents a point load. A point load is the amount of weight at that specific location. So we can see here, again this being the second floor, the weight of the walls above this point, plus the weight of the roof trusses above that, plus the weight of any snow or people or anything else on top of the roof. We expect this to hold a weight of 9,195 pounds. Looking down here, we can see the weight intensified very, very greatly. It went from 9,000 pounds up to 36,000 pounds in that one location. And as I mentioned before, when we looked at the foundation plan, there was an interior footing. Well, that was to carry this weight through a post that's transferred down to the garage level. As you work your way around the other portions of the house, you can see the different weights that are calculated.